Chapter 3, Decisions, Part 6. So it's important when developing test cases to cover all decision points. There are two possibilities in our example from the last part with our tax table. There are two possibilities for the marital status and two tax brackets for each status, yielding 4 test cases. Test a handful of boundary conditions, such as with our tax brackets, test 32,000, test 32,001, test 31,999. So test those boundary conditions so that you can make sure that your code, your if statements behave as you want them to. It's very common to use less than or equal to when you intend to use less than, and vice versa. If you are responsible for error checking, such as discussed in section 3.8, also test for valid input, such as negative income or a marital status of Y, and so forth, so that you make sure. You never know what your user is going to do. You want to make sure that you test for things that you don't expect. So here's an example of choosing some test cases where we test the boundary conditions and we test each branch. We want to make sure when we're testing that each branch is tested. Thorough testing, the importance of thorough testing cannot be overstated. There are many examples of times when software was not thoroughly tested and the code did not behave as expected after it was deployed. And we absolutely want to avoid that. Sometimes the software is so important that lives could actually be at stake if the software is not tested well. Boolean variables are variables that are true or false. We often call them a flag because we can set the flag up to indicate that it's true or down to indicate that it's false, figuratively, if not actually. We can set a Boolean variable as follows. Boolean failed equals true. So we're providing the data type, Boolean, and that is a primitive type. Boolean is a keyword. Failed would be the identifier for that Boolean variable. Equals true. True would be the initial value. True and false are both keywords, so we do not put quotes around them. They are keywords just as they are. There are 3 Boolean operators that we will be using in this class. The double ampersand is the AND operator. The 2 pipes is the OR operator. And finally, not shown on this slide, but the exclamation point is the NOT operator. Take a moment to look at your keyboard. Find the Enter key or the Return key and look just above it. You should find a key with a backslash on it. Also notice on that same key there's something called a pipe, a vertical bar. That's the symbol that we use to make that OR operator. I'm sorry, let me go back just for a second. When we're using the Boolean operator AND, it means both. The AND is a binary operator, meaning it has 2 operands, and the condition on the left and the condition on the right of the AND operator must both be true for the AND expression to be true. With the OR operator, either the expression on the left or the expression on the right, or both, can be true for the entire condition to be true. So AND is only true when both Boolean operands are true, and OR is true when either one or both of the Boolean operands are true. So the character class, character is a class, it's a wrapper class for the primitive type char, and it has some handy methods that return a Boolean value, such as character.isDigit ch. That will test the contents of the character variable ch, and if it contains a digit, it will return a true. Examples of digits are 0, 1, 2, 3, 4, 5, and so on. Other handy methods are isLetter. It will return true if the contents of the variable in parentheses is an A, B, C, D, and so on. IsUpperCase will return a true if it's an uppercase letter. IsLowerCase will return a true if it's a lowercase letter. And IsWhitespace will return true if the contents of that character variable are space, new line, or a tab. Now here's an example of combining conditions using the Boolean operators. Both, as mentioned before, both the left and the right hand operands around the AND operator must be true for the expression to be true. So if we were to test all different possibilities of those Boolean expressions, we would have 4 different conditions. Let's say that A in this table represents temp greater than 0. Temp greater than 0 can either be true or it can be false. Let's say that B represents temp less than 100. That expression can either be true or it can be false. So when we're looking at an example of both Boolean expressions, they can both be true. A can be true and B can be false. A can be false and B can be true, or they can both be false. So A and B test to make sure that A is true and B is true. If it happens, then the expression A and B is also true. That's the only time that A and B is true. In all other cases, A and B is false. Let's take a look at a truth table for the OR expression. Let's assume that A represents the Boolean expression balance greater than 100, and B represents the Boolean expression credit greater than 100. They can both be true. A can be true and B can be false. A can be false, balance could be less than or equal to 100, and B could be true, credit greater than 100, or they could both be false. The OR expression returns a true if either one or both of the conditions A and B are true. So A and B is true, then A or B is true. If A is true and B is false, then A or B is true. If A is false and B is true, then A or B is true. And finally, if A is false and B is false, then A or B is false. The not operator simply negates the expression, meaning gives it the opposite of. So if the expression A is true, not A would be false. If the expression A was false, not A would be true. So if attending is a Boolean variable, if not attending or grade less than 60, we're going to output drop. That means that in this example, perhaps a student is not attending class or their grade has dropped below 60%. In the other, why are these different? I'm not sure why that code is repeated twice because it looks to me like it's the same code, so I apologize for the confusion there. If we're using the not, we might try to use more simple logic. If attending and grade is greater than 60 might be more simple than using the negation logic. Of course, that tests the opposite expression, so we'd have to change the output statements as well. The AND flowchart could look like this, where AND temperature greater than 0, temperature less than 100. However, we typically combine them inside one diamond decision because that's how it is in the code. Both of those expressions are combined into one Boolean expression. Here's an example of Boolean operators at work, and you can hit the pause button and go through each of these examples yourself, validating whether or not they are true or false.